Welcome back with another video on TryHackMe.com. This is Nazir and we are doing container vulnerabilities from task 5 to task 7 today. We are doing it under DevSecOps path on TryHackMe.com. So let's continue. Before we do anything here, let's log in to the container here. So I'm gonna put SSH root at 10.10.36.198. Okay, type yes. Password is TryHackMe123 and exclamation mark. Who am I? We are root and we are logged in. We are good to go. So let's continue from the task 5. Okay, so task 5 is vulnerability 3, remote code execution via exposed Docker daemon. Okay, there are a lot of technical stuff here, but let's see how they explain and we are able to understand it or not. The Docker engine, TCP sockets additions. Okay. Recall how Docker uses sockets to communicate between the host operating system and container in the previous task. Docker can also use TCP sockets to achieve this. Docker can be remotely administered, for example, using management tools such as Portainer or Jenkins to deploy container to test their code. Yay, automation. Okay. The vulnerability, the Docker engine will listen on a port when configured to be run remotely. The Docker engine is easy to make remotely accessible but difficult to do securely. Okay. The vulnerability here is Docker is remotely accessible and allows anybody to execute commands. First, we will need to enumerate. Okay, we'll do the enumeration, but what they're trying to say is here, if we go back to the picture, here. So if you can access the Docker engine here, and that means, and if it is not secure, there is no authentication and anything here in this list, in this layer, that means you can run a lot of other commands as well. Okay, which could basically destroy the container itself or do all weird stuff. I think this is what they meant here. So let's continue. Okay, so enumerating, finding out if the device has Docker remotely accessible. Okay. By default, this engine will run on port 2375. Okay. We can confirm this by performing an nmap scan against your target 10.10.37.198. So, okay. So let's do that. Nmap SV verbose service version, I think 2375 10.10.37.198. So let's see. Oh, nmap is not there. Nmap is not there. So where we will be running it? On our virtual machine, right? Okay. Let me exit and then let's run nmap here as well. Now I'm running on my attack box, okay, rather than running it on the container. 10.10.37.198. Let's see if it does work. I think it's working. It will take a little bit of time to scan our IP address here. Okay, so what they are showing here, nmap scan report for Docker host, which is this one. Host is up, not shown 65531 close ports, and they are showing that okay, port 2375 TCP is open and service name is Docker and version is Docker, and this is the version number here with the API. Okay, I don't know why it is not showing any of the output here. Yeah, it's working. Service scan timing 0.00% done. 0.00% done. Why it is that? Did we? Okay. Wait. we did not put the right IP address, which is 10.10.30.237, I think. Wait a moment. Let me check. No. We put the right IP address, by the way. 10.198, but why it is taking so long to do it? 1037, 198, port is already mentioned, and map. I don't know why it is taking so much time, but let's continue. Looks like it's open. We are going to use curl command to start interacting with the expose Docker daemon, confirming that we can access the Docker daemon curl and then the version number here. So let's try this in another terminal here. I'll paste the command and it is working. So I will keep nmap running. So once it is done, we'll get to know what is going on there. And in the meanwhile, let's move on. Executing Docker commands on our target. For this, we will need to tell our version of Docker to send the command to our target, not our own machine. We can add the H switch to our target to test this. If we can run commands, we will list the container on the target. So let's do that. This time I will type the command by my hand, so I know this is available. 10.10.37.198, and I can remember as well. PS. Okay, so before I execute, let's see, we have result back. As you can see that the port is open to 2375 TCP. It is open. The service name is Docker and version is 201020. MAC address is this one. Service detection performed. Please report any incorrect result on this, and we get the result. Okay, so we were scanning some IP address on computed some internal name here. Most probably it is on AWS. Okay, so let's run our Docker command here. Okay, we are running. Okay, so we know that there is a Docker which is up, and the image name is Docker test, and then this is the command and whatnot created by, and then it is status is up. Status is up 19 minutes ago. Container ID is this one. Okay, so the image ports are this one, 22 TCP, and then the I don't know what is that, and they created by something beautiful underscore pasture. Okay, so let's continue with our commands here. Okay, what now? Now that we have confirmed that we can execute Docker commands on our target, we can do all sort of things. For example, start containers, stop containers, delete them, or export the contents of the containers for us to analyze further. It is worth recalling the command covered in the intro to Docker. We covered a lot of commands. However, I have included some commands that you may wish to explore. Network ls used to list the networks of containers. We could use this to discover other applications running and pivot to them from our machine. So let's run this one. Not this one. Let me go to the other here. Let me close this one so we are not confused. Let me run network ls. Okay, so we have a lot of network here. We have host network ID here and the bridge one as well. There is null network as well. This image is used by containers. The data can be exfiltrated by reverse engineering the image. Okay, so this is important stuff, guys. I mean, if you can get the source code, you can do pretty much everything. Okay, so we misspelled it. It should be images. Oh, we have a lot of images. Alpine, Ubuntu, and Member, and whatnot. execute a command on the container, run the container, or whatnot. Okay. What port number by default does the Docker engine use? 2375, I guess. Yeah, that is the correct answer. Let's move on to task 6, vulnerability 4, abusing namespaces. Okay. Task 6, vulnerability 4, abusing namespaces. What are namespaces? Namespaces segregate system resources such as processes, files, and memory away from other namespaces. When processes running on Linux will be assigned two things: a namespace and a process identifier, PID or PID. Namespaces are how containerization is achieved. Processes can only see the process in the same namespace. Take Docker, for example. Every new container will run as a new namespace, although the container may run multiple application processes. Let's prove the concept of containerization by comparing the number of processes on the host operating system in comparison to the Docker container that the host is running, and Apache 2 web server. So PS auxiliary, PSAUX. So these are all the things that are running in our machine, not on the Docker container. As you can see, we have a lot of processors. Where is PID? Okay, so this is the PID ID 1. That means it is running has been initiate. Okay, this is the first command that runs, and all others are the children of this init. Okay, let's move on. We saw that in the first column on the very left, we can see the user, the process is running as, including the process number, PID, PID. Additionally, notice that the column on the very right has the command or application that started the process, such as Firefox, Genome, Terminal. It's important to note here that multiple applications and processes are running, especially 320. Especially 320. I can see 300, but where is 320? 320s, I can't see. Maybe these are running on the Docker machine itself, right? The container itself. Wait a moment. Let's run here. Can I run like PSAUX here? Docker don't have this command, so we cannot run. Okay, so there is no further command here. I don't know if how to run this, but maybe we can run and then PSAUX. This is what they're trying to say here. Okay. Let's list the processes running in our Docker container using PSAUX. It's important to note that we only have 6 processes running in this example. The difference in the number of processes is usually a great indicator that we are in the container. Okay, so that means we need to log into container, right? SSH root. What was the IP address of our machine? 10.10.37.198. TryHackMe 123, and we are here. So let's run the command again since we are in the container now. PSAUX. Oh, I see a lot of processes, and I don't see 320 here either. Okay, let's continue. We have a lot of processes running here. However, we can, as we come to discover shortly, this is not 100% indicative. There are cases where, ironically, you want the container to be able to interact directly with the host. Yeah, so we know that container can interact with host directly if it is a privileged container. Okay, other than that, it cannot interact. go see the previous video on the YouTube playlist. You will find all the details that we had discussed. How can we abuse namespaces? Recall C groups, control groups. In a previous vulnerability, we are going to be using these in another method of exploitation. This attack abuses conditions where the container will share the same namespaces as the host operating system. That means there is only one way it could do if it is a privileged container. And therefore, the container can communicate with the processes on the host. A privileged container means it have privileged image installed on top of it. Okay, you might see this in cases where the container relies on a process running or needs to plug into the host, such as user debugging tools. In these situations, we can expect to see host processes in the container when listing them via ps auxiliary. Okay, what is the indicator? How we can see that here? I can see user bin, k worker, a lot of others, but how we can differentiate? There is no discussion on that. Okay, the exploit for this vulnerability, we will be using ncenter namespace enter namespace enter. Okay, this ns enter, this command allows us to execute or start processes and place them within this same namespace as another process. In this case, we will be abusing the fact that the container can see sbin in it. Can we see that? Yeah, we can see that. That means the host processes, we can see that. That means our container is privileged container. On the host, meaning that we can launch new commands such as a bash shell on the host. Okay, use the following exploit, which does the following. Okay, let's use it and let's see what it does exactly. Okay, I'll just press enter. All right, we got root thm. All right, that means our exploit did work. Okay, so what it does, we use the target switch with the value of 1 to execute our shell command that we later provide to execute in the namespace of the special system process ID to get the ultimate root. Yeah, so we executed in the same namespace as sbin init, which already have the root access. Okay, so that means we can do pretty much anything on this namespace or on this host, on the host where the container is basically hosted. Okay, specify mount. This is where we provide the mount namespace of the process that we are targeting. If no file is specified, enter the mount namespace of the target process. Okay, so we entered nothing. That means they will use the namespace of the target process. Okay. --uts, which allows us to share the same UTS namespace as the target process, meaning the same host name is used. This is important as mismatching host name can cause connection issues. So we are also passing --uts. Basically, it will also take the host name of the target. Okay. And then --IPC switch means that we enter the inter-process communication namespace of the process, which is important. This means that the memory can be shared. Yeah, this is very important. We learned in this room that the IPC can be done through sockets. And if we enable this command, that means the inter-process communication will be enabled through sockets, okay, which is very fast. And Redis also use inter-process communication. That's why it is very, very fast and very performant. The net --net switch means that we enter the network namespace, meaning that we can interact with the network related feature of the system. For example, the network interface, we can use this to open up a new connection such as stable reverse shell on the host. Okay, so we also passing the net, so we have the access to the network namespace as well. So we are doing everything to make sure that we get the successful reverse shell. Bin bash is basically opening up the shell itself, right? Okay, as we are targeting the sbin init process 1, although it's a symbolic link to libsystemd for backward compatibility, we are using the namespace and permissions of systemd daemon for our new process, the shell. Okay. Here's where our process will be executed in this privileged namespace sh, or a shell. This will execute in the same namespace and therefore privileged of the kernel. Awesome. You may need to control C to cancel the expired once or twice for this vulnerability to work. But as you can see below, we have escaped the Docker container and can look around the host name. Okay, so let's put the host name. We already know it worked, so it is THM basically. Okay, success. We will now be able to look around the host operating system in the namespace as root, meaning we have full access to anything on the host. Okay, so we went through container to the host. All right. Perform the expired in the task on the target machine. We already done. So what is the flag located in the home? TryHackMe flag.txt. So let's do that. Cat home TryHackMe, then we have flag.txt. Here we go. We'll copy it from here. Oh, I need to copy it. I need to copy it from here. Paste here. And we are done. We are done. So all is left is conclusion. Let's go to the conclusion of this room. Conclusion. Oh, that was fun. In today's room, we learned about some possible misconfiguration with Docker containers, how to discover these and ultimately exploit them. Now we might be wondering why it is in this case, the container might run with privilege that effectively bypass the security mechanism Docker introduces. Well, while it is not a recommended practice, there are use cases where containers do need this level of interaction. For example, running Docker within Docker, or specific applications such as firewalls that need to interact with the host, IP tables, or perhaps attached devices. Ultimately, there is also an element of taking the quick, easy route out. That when you don't need to make it secure, because security will always take time and effort. And if you have all the access, that means you can do pretty much anything, and that means it is not secure at all. This is what they meant by this particular statement. When trying to figure out what permission to assign a container, Docker, especially in recent time, does a great job of hardening. For example, you can give a container specific capabilities on a allow list basis. However, it isn't too far-fetched to think that people would just give more than necessary capabilities to get something to work without realizing the wider consequences. Yeah, I mean, developers usually give all the permissions that they can put their hands on, so everything should work without any hassle. So this is what they meant here. We'll come on to how we can prevent these misconfiguration and vulnerabilities in the next room, which is container hardening. I can't wait to start this room. Click me to finish the room. Congratulations guys, we have done this. If you like this video, please give it a thumbs up. If you haven't subscribed, please subscribe, and also put your suggestions in the comments below, and I will see you in the next video. Thank you. Bye bye.